Well, hey guys, this week I'm going to have you do an investigation at home of different types of levers. So you're going to need to go gather some materials that you can use to make a lever. As you know, a lever is basically some sort of a bar or a piece of wood. So I've got this piece right here. Then I also need a fulcrum or something around which that lever will move. I've taken 3 pins and I've taped them together in sort of a wedge shape so that they make like a little pyramid, and then my lever can sit on the top of that. It's like a teeter-totter for a first-class lever. Then I need some resistance. I've got a little hat right here, so I'll put the hat down here. And again, this is kind of like a teeter-totter. I need to make 4 different measurements when it comes to this arrangement. And what I need to measure is the resistance length. And this is going to look a lot like what we did with pendulums. So I'm going to measure from the middle of the fulcrum to the middle of the resistance. And that's going to be my resistance length. And then I will measure what we call the effort length. When I push down at this end and make the hat go up, I am pushing from the middle of the fulcrum to wherever my finger is. So I will measure that length. And then, so the way that would work is I just grab my ruler and I'd say, okay, from the middle of the hat to the middle of the fulcrum, in this case is about, looks like about 15 centimeters. Then from the middle of the fulcrum to where I would push down, looks like that's about 20 centimeters or something like that. I have attached a file that gives you an idea of what the data table may look like. So I've done that. So I just mark those measurements down. Then what I'm going to do is I'm going to actually push down, do the resistance piece, and I'm going to watch the resistance go up. But I want to measure how far the resistance moved. So I will measure from the height, from my tabletop to however high up the resistance went. And in this case, I'm just going to go to the bottom of the lever. And I'm going to say, okay, that's about, that's upside down. So that's about, 2.5 centimeters. And then I also want to measure how far did I push the resistance. Okay, that's about, I don't know, maybe 3 centimeters is how far I moved the resistance. So I've got my resistance length, my effort length, my resistance distance, how far it came up off the ground, and then my effort distance, how far did I have to push the effort down to make the resistance go up. I'm going to do that for 3 different scenarios. So that's scenario 1. Maybe I'll move this over here, and then notice that the resistance goes a long distance off the ground and my effort goes a little distance off the ground. If I measure my effort length, it's shorter. My resistance length is much longer. Then I'm going to pull this over here, and I am going to do the same thing again. Notice how far off the ground my effort would have to move my resistance a little bit over there. And then I would also measure the effort length and the resistance length. Do that 3 different times and write those down. And then you also will find the mechanical advantage for each one of those scenarios. Okay, that's it for lever 1, for a first-class lever rather. Go out and get your materials and do that investigation. When you're done with that, take a look at the next video and do the same thing for a second-class lever. Okay?